Good day, everyone. I'm Jaswinder Singh, the principal trainer at Smatrix Consultancy. I specialize in quality and management excellence. Malaysia is at a defining moment in its industrial evolution, the fourth industrial revolution, IR 4.0. It has redrawn the map of global competitiveness. Success now demands more than low-cost labor and assembly line efficiency. It demands vision, creativity, and ability to design and control systems with precision. Our Prime Minister, Dato Sri Anwar Ibrahim's directive to produce 60,000 highly skilled semiconductor engineers is not simply an economic goal. It is actually a national reset. It is a signal that Malaysia can no longer rely on low-cost assembly to compete in the global economy. This reset does not apply to semiconductors alone. It is actually a wake-up call for the entire engineering community across all sectors. Whether in manufacturing, power, automotive, biomedical, infrastructure, defense, every engineer must now be upskilled, reskilled, and retrained to meet the demands of an IR 4.0 driven world. Our Economy Minister, Dato Sri Rafizi Ramli's remark, underscoring the difference between made in Malaysia and made by Malaysia. This further emphasized the urgency of transformation. It is not enough to participate in someone else's innovation chain. We must design, own, and lead the chain ourselves. We have heard calls like this before. In the 1980s, the Dasar Pandang ke Timur, Look East policy was introduced as a national strategy to emulate the industrial and societal discipline of Japan especially, and South Korea. But this adoption stopped at the surface. We mimicked the cultural element, but we neglected the core system and philosophies that made the East industrial powerhouses. We failed to ask the more important question: Timur pandang siapa? To whom exactly were we looking in the East? The East succeeded not simply through cultural discipline, but by embracing the philosophies of our great quality gurus like W. Edward Deming, Yosef Juran, and Genichi Taguchi. These quality gurus were the architect of modern industrial quality. Their frameworks were not academic luxuries. They were foundation of Japan's and South Korea post-war economic miracle. Deming's statistical thinking revolutionized process control. Juran's focus on quality planning and management transformed leadership system. Taguchi's robust design methods drove down costs while elevating product reliability. These gurus gave the East the tools to create world-class industries, from automotive to electronics, long before smart manufacturing became a global buzzword. Smatrix has fully embedded these teachings and methodologies into its training framework. We do not merely mention quality gurus at footnotes. We bring their principles to life in every courses, lab, and real-world project. Deming's system thinking, Juran's breakthrough management, and Taguchi's robust optimization are now core to how we can train our engineers to think, act, and lead. This is not theoretical appreciation. It is a practical national transformation engineered to push our nation towards becoming an industrial powerhouse in this century. What further complicates this evolution is the changing nature of engineering itself. In IR 3.0, engineers and IT professionals occupied separate domains. One focused on physical system, the other on digital logic. But in IR 4.0, those lines have blurred. Cyber-physical system, smart devices, cloud-based automation, AI-powered design, data-centric decision-making have made it so that engineers must now master both hardware and software. They must speak both design language and code. Indeed, this convergence adds pressure but also opportunity, provided we are willing to reskill and upskill our engineering workforce comprehensively. Earning a degree, diploma, or even a master's is no longer the finishing line. It is merely the starting point. The true journey begins not in campus, but on the factory floor, in the R&D lab, and within live operational environments where systems rarely behave as expected. The constraints are fixed, and every failure comes with real consequences. This is where textbook theory collides with industrial reality. It is here that applied knowledge, system-level thinking, and relentless process improvements are no longer optional. They are survival skills. Engineers who treat graduation at the end of their learning journey, will find themselves obsolete in the world that evolves faster than their qualifications. To understand why this shift is unavoidable, two powerful trends must be acknowledged. First, the knowledge doubling curve. This concept, originally introduced by Buckminster Fuller, shows how fast human knowledge is expanding. In the 1900s, global knowledge was estimated to double every 100 years. By 1950, it halved to about 25 years. Today, in the era of IR 4.0, where big data, AI, IoT, cloud computing, and knowledge in many technical fields, including engineering, is estimated to double every 12 to 18 months. Some emerging areas like medical diagnostics and chip architecture are accelerating even faster. Second, the half-life of knowledge. Just as radioactive elements decay over time, so does the relevance of engineering expertise. The half-life of knowledge, the time it takes for 50% of one's professional know-how becomes outdated, has shortened dramatically. In modern engineering field, it is now estimated to be just 2 to 5 years. This means that without ongoing learning and skill renewal, even top graduates risk becoming irrelevant in less than a decade. We are now living in an era where knowledge doubling and knowledge half-life are redefining what it means to be competent. This makes lifelong learning and continuous upskilling not a luxury but a necessity. It also makes Smatrix mission more urgent than ever. Malaysia missed the depth in previous revolutions. We focused on output but neglected structure. We focused on speed but ignored quality. And most critically, we train our engineers to be tool users rather than system creators. We, in Smatrix, would like to work together in correcting this course. We are not just a training provider. We are an industry-aligned national transformation platform, built to empower engineers, technologists, and technicians for the realities of IR 4.0. Our mission is clear: to produce professionals who can both envision and execute, who understand not just how systems function, but how to create, improve, and lead them. Our programs address the two most critical national needs: what to make and how to make it. What to make is about empowering Malaysia's engineering workforce with future-proof technical mastery. Smatrix delivers structured, hands-on training in digital and analog electronics, VLSI design and verification, FPGA and digital system, embedded systems and IoT, PCB design and power systems, and ASIC. These are the foundational technologies of IR 4.0, the essential domains behind smart devices, intelligent automation, high-speed communication, and real-time decision-making. Our trainees don't just use existing platforms. They learn to design, simulate, test, and optimize systems that will drive innovations in every sector. Our learners graduate with the confidence to build tomorrow's products, not just maintain yesterday's tools. At the heart of it, design is now a non-negotiable skill. Every engineer must become proficient in design, whether it involves hardware systems, digital architecture, process flows, or customer-centric products. Design is where value begins. It is where control is retained. It is where ownership is created. In IR 4.0, design is power. But design means nothing without execution. This is why Smatrix also focuses intensely on how to make. This is where Malaysia has struggled most, with inconsistent processes, unreliable data, and outdated quality frameworks. Smatrix addresses this by embedding world-class methodologies into our programs, including reliability engineering, measurement system analysis, statistical process control, design of experiment factorial, design of experiment Taguchi, design for Six Sigma, regression and predictive analysis, and many more. Each of these methodologies reflect the enduring contribution of Deming, Duran, and Taguchi, whose teachings were applied directly to help industries to reduce variation, improve consistency, and deliver defect-free products. Their legacies are not just academic, They are practical frameworks for national competitiveness. China's rise as today's industrial superpower was not a mere coincidence. It invested heavily in technical education, engineering design capabilities, and advanced manufacturing while systematically mastering and localizing the very tools that the West and Japan once used to dominate. From semiconductors to renewable energy, from high-speed rail to robotics, China achieved this by embedding continuous learning, process optimization, and quality disciplines at every level of its production ecosystem. If Malaysia is to compete with the East, we must do the same. And that is precisely what Smatrix is doing through its current course offerings. Smatrix courses are developed to address this need holistically, bridging design, execution, quality, and innovation across every major industrial vertical. Each engineer must now choose a path: master what to make, or master how to make, or for those truly determined, mastering both. The era of narrow technical focus is over. The future belongs to those who can innovate, troubleshoot, and scale across both domains with confidence and agility. Smatrix programs are professionally recognized by the Malaysian Board of Technologies and Board, ensuring that our graduates and participants meet the standard expected of future-ready technologies and engineers. Our certifications are also endorsed by IQM and are HRDC claimable, reinforcing our commitment to national skill development. Our labs are equipped with industrial-grade tools, real-time simulator, and advanced software environments. We don't teach theory, we train for implementation. With platforms like Xilinx, Altera, Eagle, System Verilog, quality statistical tools, and real-world diagnostic instruments, our programs simulate actual industrial challenges and prepare participants to solve them with competence and confidence. The courses Smatrix offer today are not just relevant, they are crafted to address this future. We are committed in developing more IR 4.0 courses. This is just the beginning. This is not about one industry. This is about building Malaysia's industrial DNA. We cannot do it alone. We need your support. We invite you, engineers, graduates, companies, government stakeholders, to come and join us, learn from us. Not because the engineers of tomorrow are waiting in foreign universities, not because we need to rely on high-paid expatriates to tell us what to do, but because it is you, the local talent, who will define Malaysia's future. Come, join us, build with us, transform with us, design the nation's destiny with your own hand. We should not outsource our future. It must be engineered here in Malaysia. At Smatrix, you will come as a trainee, but you will live as a consultant, quality champion, and designer. The time is now. We cannot afford to wait. Malaysia cannot afford to wait. Our global competitors are already moving, designing, innovating. The question is, will we be the nation that follows or the one that leads? Smatrix believes we can lead, but we need you to step forward, join us, let's create the future together.